Hey, what's up? Let's do some math today. In this video, we're going to talk about problem solving with proportions. Now, we got to start off with a little bit of a warning. First thing, everybody's favorite, word problems. We're going to be going over word problems, which means that we're going to have to be able to stick with it. And so that's what I'm going to ask of you. So stick with it. You need some persistence. The way these word problems work, you're going to look at it and you're probably not going to know the answer right off the bat. That is how they are written, but that's okay. We stick with it, we unravel it, we will solve them. Now, in order to do this, we need tools. This is a tough job here. So let's first of all talk about the process and then the tools. And to kind of help explain all of this, let's just kind of imagine for an example, we're saying that we have a ratio of right-handed people to left-handed people, and that is 5 to 1. Now, for the process, the first thing we need to do is read. Because in fact, usually these problems are going to become reading problems more so than math problems. The problem might say, hey, how many righties are there? And that number, especially given this ratio, is going to be very different than if it asks for how many lefties there are in the situation. So 1, make sure you read. 2, this is big, and this is sort of a question you need to ask. Do we have a part-to-part or a part-to-whole ratio? Then, number 3, we need to think about the placement, which is something we've talked about, when we set up our ratios and proportions. So placement with proportions. And finally, pick a tool and solve. Pick a tool and solve. Now, this is where I want us to think about this ratio of righties to lefties, because we have 2 tools we can work with. So on one side, kind of a line in the sand, if you will, let's go with red, we have just good old math. Nothing wrong with it. Sometimes it can be tricky though. But so, for example, if we had a ratio of righties to lefties, we could say it's 5 to 1 like this. And then what we can do is build up and kind of ask ourselves, well, hey, if there are 10 right-handed people in a group, how many left-handed people are in that group? And you can just do the math to figure out that your question mark here is equal to 2. Now, sometimes math is a very good tool to use. Other times, it's actually not the best tool. So there is this other method that we'll call sort of the tape method. And what that is where we are going to draw it out. So we could go 1, 2, 3, 4, 5, and then 1. And this uses what I like to call, or they're called tape diagrams. Spaced on it for a second, so tape diagrams, much better. We're using the best tool ever invented in technology, which is copy and paste, where we just copy and paste this until we get what we want. And so if we're saying, hey, if you have 10 righties, how many lefties are there? Well, let's just copy this ratio until we have those 10 righties. So we would go 1, 2, 3, 4, 5. This 5 plus that 5 is 10. And then we just copy that L, count up all those L's, we have 2 lefties. And we've done no math. We've just done copying and pasting. So those are the 2 big tools I want to show you. We have our proportion skills, but we also have tape diagrams. So let's take a quick look at a couple of word problems and kind of see them both in action. All right, so right here, the ratio of boys to girls in a class is 4 to 3. If there are 16 boys, how many girls are in the class? Well, again, let's kind of do a line in the sand, and on one side, let's do the math approach. So here, placement matters. Boys to girls, 4, let me zoom in a little more, over 3 is equal to something. Now, I like to put a little letter here to say, hey, that's 4 boys, this is 3 girls. The other piece of information I'm given is that there's 16 boys. So I want that in the numerator on both sides. The girls, I don't know yet, so that's going to be a question mark. Then I play my proportional game. What do I need to multiply 4 by to get 16? That's 4. Take this, times it by 4, and there are 12 girls in this class. Now that's the math way. If I were to use the other trick, the tape diagrams, I will have 1, 2, 3, 4 boys, 1, 2, 3 girls. And what I'm going to do is just copy and paste this a couple of times until I have 16. Geez, that doesn't look like sixes. Oops. 16 boys. So just keep on copying and make sure every time I maintain both the same amount of boys and the same amount of girls. Because if there is this ratio existing in the class, it's got to break down like this to where we have all these little groups of 4 to 3. Well, now I have 16 boys. I can count up all the girls. Got 4 groups of 3, 12 girls. So sometimes the tape diagrams are handy. Sometimes I'd argue math is a little bit easier. Now, this thing, and I kind of skipped over it, this was a part-to-part proportion problem where we were talking about boys to girls. This next one is a part-to-whole problem. So the ratio of boys to girls in a class is 4 to 3. So it's like the same numbers, but a slightly different problem now. If there are 42 students in the class, how many girls are in the class? So here we're doing with a part to whole because there's 42 students in the class. Now, this is where the tape diagram comes in very handy. 1, 2, 3, 4, 1, 2, 3. What I'm getting from this is that there is a total of 7 people in one ratio. Okay? And so I can then rearrange this and make it a part to whole. Because right here, this is part to part, but what I want to be able to do is get it part to whole. Then I can set up the proportions. So here, if I want to talk about 42 students in the class, how many girls there are 3 girls for every 7 students in total. So my new ratio is 3 girls to 7 total students. Now I can cook up the other proportion. And to that I'd get 42 total students. And then I play the multiplication game. I'd have to times that by 6. I'd have to times this by 6. And there'd be 18 girls in this class of 42 students. Now again, the tape diagram could also maybe help us look at like what we're going to need to multiply either one of these by. I have 7 total students. I could ask how many copies of this I need to get to 42. And I would have to do this copy 6 times, and then from there I could either times the 4 by 6 or the 3 by 6, depending upon what I was asked to do. And again, sometimes I might give you the same question, but just swap out the word girls for the word boys, and it's kind of like a different problem, and you have to make sure you answer it the correct way. So those are 2 good examples of a part to part and a part to whole, and how we approach them. Now let's look at a super hard one. Okay, the ratio of 6th to 7th to 8th graders at a middle school is 3 to 3 to 2. How many 8th graders are there if there are 72 students in the middle school? Save the best one for last. So this is a 3-part ratio. This is definitely where tape diagrams are our best friend. So we have, let's just write it out here, 3 to 3 to 2. And this represents 6th, 7th, and 8th graders. Now let's draw it out like tape diagram style. 6, 6, 6, 7, 7, 7, 8, 8, 8. Now, let me ask, how many students do we have total in just one ratio? 3 plus 3 plus 2. This is 8 total students. Well, how many of these groupings of 8 do I need to get to get to 72? I'm going to need 9 groups. So 9 groups of these 8 sets of students, 3 6th graders, 3 7th graders, 2 8th graders. So now I can just take this 9 and times it by whichever one I need. I'm curious about how many 8th graders there are, so I'm going to go 9 times 2. That number right there. There are 18 8th graders in this middle school. compare that to 9 times 3, which would give me 27, and then 27 also for 7th graders. So even if we have a 3-part ratio, we can still apply similar tactics. So just to recap, let's go back to that first page here. You got to read, got to make sure you're answering the correct question. You got to be careful with your placement with proportions, and then pick a tool. Tape diagrams are your friend for this. They help you really visualize what's going on, and they help you do the math. Good luck with your practice, and let me know if you have any questions.